Welcome to the second episode of Let's Make a Game platformer. So in the last episode I've introduced you to libgdx, the layout of the code, as well as showed you around how the FPS logger works to be able to track our FPS of the application. So let's maybe start working now on the context class. So first of all, we will store it in our platformer class. So we have to create it here. And it requires two parameters, two or more. So first parameters is a set of active profiles. So active profiles is basically any kind of features you want this context to pull in from wherever they are available from, and where they are available you specify passing the reflections object as a second parameter to this context. So the way this all works is that first of all we specify that, let's maybe create quickly the active profiles. And pass it to the constructor. For now it's going to be an empty set. And then we specify how to pick up the classes to instantiate in the context. So we'll be scanning based on annotations. Don't worry if you don't understand this part. This is something you're going to be just copy-pasting if you want to use this library. So we'll be scanning based on annotations, on types, so on classes, and we'll be scanning everything that is in our class path. So this code, when we invoke it here, let's maybe remove the typo, scan based on annotations. So this code here basically will look through all the classes in the class path and look at annotations of those classes. And this guy here is smart, and it looks for anything, any class that has the register system annotation. So this is a very special annotation that we'll be using on anything that we want to be put into the context. As for these parameters, I'll explain in a second. So let's maybe first thing we want to do is start up the context, and let's print out what is picked up by the context at the moment. Print line systems in context. So we iterate through them. System, and we will print out the name of the class. Okay, get systems, not system. Okay, so we'll be iterating through all of them, and we will be printing them out, printing out all the systems that are available here. So what we can see in a second is that there are two systems in our context at the moment that are picked up, which is the reflections name components manager and simple game loop. Let's maybe at the moment look at the simple game loop. So it has the register system interface here, the annotation, and it says that it's sharing these two interfaces with other classes in the context. So it also implements these interfaces, as you can see here. So what this means is that if whenever you ask the context to give you a system that implements internal game loop interface, it will actually return this way, because this is what it exposes to other classes in the context. So whenever anywhere you ask for internal game loop, this is the class you'll actually get. So what we are doing with so this is standard game loop thing, where we just whenever this render method is called, we want to execute any game logic in the game loop. Let's maybe demonstrate a simple use of it. Let's create a simple test system. We want to register it, so it's going to be picked up by the context. And okay, register it, and we want to be able to inject game loop. So this inject annotation, when used on the variable in a class, means that we want the context to give this class that from context that matches this interface, that exposes this interface, shares with other systems. It's going to be injected here during the creation of the context, and we'll be able to use it whenever we wish to. Another thing you have to know about the context here is that if a system in a context implements this special interface, it is going to be notified about events that are basically in the life cycle of this class. So, for example, one of the methods we will be receiving is initialize, not initialized. Initialize, yeah. And it's going to tell us to override. So when context will be creating this class, after injecting on the other classes to it, it will call initialize on each class that has this lifecycle system interface on it. And in here we want to say that we want to be listening for game loop events, and game loop listener is how we're going to be registering it ourselves. And now we will say that we want to implement update method. So the game loop will be called on each refresh on each of the render methods. The game loop that we are telling it to update will be calling this system update method. So let's print out here update called, and let's run it and see what happens. Okay, so visual nothing happens, but we see here a lot of system out print lines being called. So first of all, we see that this class is being picked up by the context, and second of all, the game loop actually does call this method. So we are not. So in here, we are only invoking the process update of the internal game loop interface, which in fact makes the game loop call process method, update method on each system that is registered with the game loop. So now maybe I'll try to quickly show what happens when we want to go into profiles. So let's say this class requires a test profile to be called. So let's run it now. So this is the only thing we've changed. We just said that this class requires a test profile. So what now is going to happen is that this class is not picked up by the context, and the update code is not called because this is not called and this is not called. So what we can do to get it called again is to specify that the test profile is actually has to be active for this context. So what's going to happen is now the context is going to see that, sorry, not test profiles, but test profile. So it's going to take a look at the test system class while scanning and see, okay, it requires test profile, but test profile is indeed active, therefore it's being called here. And everything is working. Okay, let's quickly remove this test system. We don't need it. And let's actually do some actual rendering, maybe, because black screen is quite boring. So you could write your own rendering pipeline. It's a pretty complicated stuff, but you don't have to. There is one available in the gaming module here, which is called 5-phase master renderer, and it's activated with a 5-phase renderer profile. So let's activate it. So why is it 5-phase renderer? Because it has 5 phases of rendering. First of all, it draws everything in the background, so the backdrop. Then it renders anything in the scene, like the environment, like player character, platforms, I don't know, anything that you can imagine. But this is the thing that now it also has post-environment renderer. The difference between these two is that whatever is rendered in the environment renderer casts shadows if you enable them, and everything that is rendered in the post-environment renderer does not cast shadow. This is, for example, the post-environment renderer. One of the uses of it is for particles. This is something that I'll probably introduce at a later point. Then we have the post-processing phase, which is basically applying any filters like bloom, blur, or anything else you want, any other post effects you want to apply to the screen render to the user. And then finally we draw user interface on top of it, like buttons, any other things that should not be affected by the blur or bloom or any other effects. So this is the 5-phase renderer. So as we can see, it requires 2 things to be injected. So, but however, the first one, the directional light provider, which is used for casting shadows. So in order to cast shadows, you just have to provide this interface in the context. So this is optional. For now, we will not be using it. It's a fairly complicated thing to do. So let's just go with this. So this rendering entity provider specifies basically how do we render stuff to this 5-phase master renderer. So this specifies what kind of post-processing effects should be applied, as well as where is the camera, where is it pointing at in the world, where is up for the camera, and stuff like that. So in order for it to run now, let's try to run it with this 5-phase renderer. We will see that it is gonna fail. Yeah, it's gonna say that the 5-phase master renderer has asked for rendering entity provider, but none was found in the context, which is true. We don't have it, and we don't have an implementation for it. That's because we have to write one. So let's add a package here, rendering, and let's do platformer rendering entity provider. So it has to be a system, so we have to register it, and it has to implement rendering entity provider. Awesome. So the rendering entity provider has interface has two methods. First one is returning the entity that is responsible for rendering. This is, you can think of it as entity is anything in the game. It can be a player, it can be a camera, it can be a platform, a ball, an enemy, a missile being fired, anything you want, an item dropped on the floor, or anything in the game. Entity. It's like object in Java. It's just something. By itself, it doesn't mean anything, but it has these special properties which are called components that can be added to it, removed, modified, and so on. So what this is used for by the 5-phase master renderer, which is calling this method, is that it's looking at the components that this entity has. And for example, one use of it is that if this entity has a bloom component, this particular rendering entity, then a bloom filter will be applied. If it has blur component, then a blur effect will be applied to the whole scene, and so on. So we have to return an entity here, but first we have to create it. And in order to create an entity, we have to use something else that we get from the ECS, so the Entity Component System, which is Entity Manager. So, and we want to create it only once. So we once again gonna implement the lifecycle system and public void initialize. So in here we'll do Entity Manager, create entity, and we have an entity. Let's store it somewhere here. Let's call it camera entity, and we'll do camera entity, and we will be returning it here. Awesome. Second things we need to do, other than specifying what is the entity that describes the rendering, we also have to set up the camera. So where the camera is within the world, like XYZ coordinates of it, where it is looking at, what is it looking at, where's the up direction, and so on. So let's do this quickly. Camera position set 005. So 5 in the Z direction. We'll be looking at 000 at the origin, and we'll specify that the up direction for the camera is Y is up. So we have XZ in the screen coordinates, XY in the screen coordinates. When Y is up, X is left and right, and Z is away from the screen or into the screen direction. So we are away from the screen, we are looking at 000, and the up direction is 1. So other thing we have to do is pull in the entity manager, and to do that we have to, this is one of the ones available that we have, so we'll activate it quickly. And this entity manager requires a component manager. I prefer the name convention, components. I'll explain the components a little bit later when we'll be using them. For now, we will, in this at least episode, we will not use them. It's really difficult to bring all the context and entities and components in one short explanation, because they are so interconnected together. That's why for now, just trust me, this has to be what has to be done. I'll explain everything else on the components later. So we are bringing in the entity manager, something that is able to understand components, and we now have to render stuff now. So get system, rendering engine. This is the interface that is exposed by the 5-phase master renderer here, rendering engine. So from our platformer, we'll call render on it. Awesome. So we'll be rendering now. Let's hope. Let's see what's happening. If anything crashes or is everything fine. Okay, we have to provide a rendering entity provider. And we have not said that this class that we've created is actually exposing the rendering entity provider to all the other classes in the context. So let's do it quickly. And okay, great, everything's working. However, our screen is still black. That's because we are not rendering anything yet. I'd like to leave the rendering to a later time. However, what I can do very quickly is just render a solid background. We don't have to do anything very complicated here. We just have to use one of the classes that is provided in the gaming module, which is a background renderer. We turn it on by adding background renderer as an active profile. However, the background renderer requires background color provider. Basically, we have to tell him what color we want to render it with. So since we might want to be able to use different colors change the colors, morph the colors. So we have to, rather than setting directly like one color, we have to create a class that's going to be telling what's the color at the moment. We have to register it in the context. We have to say that we are sharing the background color provider class, and we are implementing the background color provider interface, which has one method which returns a background color. So let's quickly create a color here. Vector 3 background color, and let's make it a nice light sky blue color. I have it written down here, 186 and 220, 255. Okay, so let's return it here, background color, and let's run it now and see if our nice sky blue color is working or not. It's working. So yeah, we have something rendering already. Nothing great, but it's just a couple of minutes in, so there we are. Thank you for watching this episode, and I hope you're gonna continue watching this series. Thanks for watching. Bye.